right, guys, let's get started. So thanks for joining us today. So today we're going to be talking about how Johnson Controls built an intelligent cloud application. My name is Romit Girdhar. I'm from Microsoft. I've got Tony Giudici. Sorry, I keep messing that up.
Nobody
from Microsoft as well. But believe it or not, we're actually not going to be doing much of the talking. We've got Justin Ploegert here with us, who actually has the most amazing title I've ever seen for a cloud engineer. His title is actually a Cloud Sherpa. But he's with Johnson Controls, and he's actually gonna spend the most of the time today talking to us about how they've built their cloud solutions at scale and how they've been using the different Azure services and getting them to work together and piecing them together. So it'll be a nice high-level solution, or we'll talk through some of the details and so on and so forth. But before we go into the details, I just wanted to set some expectations. This is not a marketing session. We're not here to sell you on any one technology or sell you on any one solution. We're also not here to talk about any one feature about any one technology. We're here to tell you a platform story, because that's what makes Azure great, is the fact that we are an end-to-end platform. So that's what we'll try and cover. What this session is about, though, it's about learning from a real customer and a real scenario of how they've built a cloud solution, how they've migrated their solutions from on-premises to Azure, what their journey has been. We'll learn about how they've architected, how they've designed it, what were some of the decisions they took, why they chose to go with one service over the other, what were some of the benefits, what were some of the challenges, because not everything goes as smoothly and as planned. And so that'll be something we'll talk about. And finally, we'll also share some best practices and some pitfalls to look out for as you guys go through your journey as well. Some session takeaways for you guys as you guys walk out of here. We'd love if you guys could take away a few things. Most importantly, how to piece all these different services together. How do they talk to each other? How to correctly architect your solutions, for Azure and for cloud scale in general. I mean, we're all used to designing solutions on premises, and it's radically different to design and architect solutions in the cloud, as opposed to something on premises. Another thing we'd like to try and convey here is how Microsoft Azure is flexible enough for you to build your solutions. You learn from examples how Johnson Controls has actually built their own time series database on Azure, even though we have a managed time series offering as well. So we'll learn about why and how that happened as well. And finally, just something to take away, which is when to use what. That's a question we get quite often, which is when do I use what kind of services in Azure? What's the difference between data lake and data warehouse and so on and so forth? And it can get confusing for everybody. And so we'd love if you could take that as well. With that, I actually want to hand it over to Justin to lead us and talk to us about who Johnson Controls are and what they do. Justin.
Hi, everybody. Great to be here. Glad that we could be up on stage here with Microsoft and kind of talk about our exciting journey into the cloud. We had kind of a very diverse experience, and I'm just happy to be able to share some of the bumps along the road and some of the knowledge that we learned on the way. But first, a little bit about Johnson Controls. Our business is primarily about taking care of buildings. Who here's been in a building before? No, none of you guys? You guys are in a building, Who wants to be comfortable in a building? Anybody? Okay. Well, Johnson Controls helps make that happen. We specialize in building automation and control, as well as fire and security. So all the things that go into making a building work, and the mechanics, the engineering, all that kind of stuff, that's the things that we care about. And how this is relevant to our Azure experience is all of these buildings have all this equipment in it that has sensors, and we want to get a hold of that data. And so that's what a lot of this presentation is going to be about, and hopefully you find it eye-opening. But first, where did Johnson Controls come from? Our company got started by a guy named Warren S. Johnson. He was a professor at University of Wisconsin-Whitewater, and he decided that one day that the rooms were too hot or too cold, and all the college students were complaining, so he set out to try to create a device that would let him know and be able to control the temperature of those rooms. And so his first invention was the electric telethermoscope, otherwise known as the thermostat. And so in 1883, he patented that design, followed by a couple years later, a pneumatic version of that. But really, that was the first big invention that Johnson Controls came up with, and it's kind of been central to our ethos of what we're trying to do at Johnson Controls. We do a lot more than just building control. We also do batteries. In North America, we make some of the, I think it's like 75% of the batteries or something in cars. Don't quote me on that statistic. I'm not exactly sure the number, but it's a large percentage of car batteries. And I never even knew that until I started working at Johnson Controls. But it's a great company to work for. You may have recognized some of the buildings that we've worked on. These are huge, tall, 90% of the world's tallest buildings that we're in and that we're helping manage and control. That includes going all the way to the Antarctic, all the way to controlling submarine vessels and making sure that the environmentals are correct on that. You can't really call tech support in a submarine other than the people that are on there, so it's important you get it right the first time, right? So we have a short little two-minute video that is a little bit about a technician speaking about kind of his experiences and why acquiring data is so important to him. And it's kind of the key driver in why we're here and why we had to solve some of the problems that we needed to solve.
I've been a technician all my life, and working for Johnson Controls has shown me how the smallest detail can have a huge impact. You might be surprised to hear that buildings consume 47% of global energy, and about half of that is used by chillers. It's my job to keep chillers operating at peak efficiency, so energy costs and carbon footprint shrink. In hospitals, the wrong temperature in operating rooms can affect patient care and delay procedures, frustrating patients. With reimbursement dollars tied to patient surveys, unhappy patients can lead to lost dollars. By using Microsoft's data solutions with our smart connected chillers, I can monitor performance from anywhere, giving me the information I need to identify and respond to issues before they turn into costly problems. In colleges and universities, the cost of education has risen nearly 400% in the last 30 years, making cost control a hot topic. Through proactive maintenance, simple things like keeping tubes clean can reduce energy consumption by up to 35%. For a university with 250 buildings, savings could add up to $1.75 million annually. And in manufacturing, where elevated temperatures can quickly shut down a production line, uptime is everything. Using advanced diagnostics, I was able to proactively identify an issue for one of my customers and make a fix during a scheduled shutdown, saving them $300,000 an hour of unplanned downtime. Johnson Controls invented the thermostat in 1885, and we've been keeping people, businesses, and vital machinery cool, comfortable, and safe ever since. Now with the Microsoft Cloud, chillers are more energy efficient and buildings get more intelligent every day. The Internet of Things and advanced analytics help me make the world run more smoothly, safely, simply, and smartly. Johnson Controls and Microsoft. Keeping things cool.
So, I'd like to start out with something easy in the beginning. There's three things that I want you to pay attention to, and there's some of the thematic things that I'm going to be talking about, and I think that you'll kind of see that we keep repeating these themes over and over again. The first thing that I want to mention is avoid focusing on technology, focus on outcomes. The second theme you'll see is, learning hurts. It's really important to develop great partnerships with key technology vendors, and not just key technology vendors, but also coworkers or the internet community as a whole. And third, fail fast, fail often. Getting rapid feedback to whether or not you have the right solution is imperative to any good solution that you're rolling out. And if you want some extra credit, these are some additional themes that we'll be talking about of designing for the real world, for architectural adaptability, security, and efficiency. So, let's fast forward 100 years from when that thermostat was first made to a more modern control system. Here, it's kind of a couple different things. You can see in the bottom left a chiller. Those were that big piece of equipment that you saw in the video. And these devices cost millions of dollars. So the investment of that equipment is very high. And to proactively be able to determine what the state of that equipment is very imperative to being able to maintain it and try to lower the consistent costs of maintaining that. So what we typically do is when you think of a big building, you can think of that it has many floors. And on each floor, you have kind of a floor controller that kind of controls the devices on that floor. And so if you think of that as each one of those devices on the left, the Connected Services NCE, those could be considered to be like a floor level controller. Then you can go up to the next level and say, okay, those floors have the awareness of just that floor, but I want to know how the building does as a whole. And so the site level controller can take all the data from the entire building and provide feedback within that site. So traditionally, when we talk about an automation control system, it's usually locally aware, right? That facility, it knows what's going on with it. But our mission is that we wanted to know at a global size of what's going on with our equipment. And what that really required is thinking about how we're doing that. So this is the data flow on a basic local, leveled device that doesn't really have cloud connectivity, right? You have a thermostat, a meter, a chiller sensor. They're talking to their controllers, and they're able to make decisions based upon what's going on there. But we are able to send data easily outbound, right? You just need to open up a firewall port, and you can connect to the internet and send data to some application, which is all great, right? You want to have telemetry of those sensors, send them up, and then I can let people know exactly what's going on with it. That's kind of level one stuff, right? That gets you so far, but what if we wanted to talk back? We wanted to be able to send command messages into the device. And that we find that that's really difficult for our customers because working with their IT departments, they need to open up ports, and that's not always a possibility or a secure thing that is easy to convince your IT folks that you need to open that port, right? So we needed to find a way that we could do this in a secure manner without having to really make things too complicated. And so that was about in 2012 when I started at Johnson Controls. We heard about this brand new funky thing called Windows Azure. Maybe you guys have heard of it. Well, they had an interesting solution called the Azure Service Bus Relay. And what this really empowered us to do was basically create kind of a central endpoint that would be able to be accessed from either end. So the device could reach out to the cloud at a specific location that would always be there. And from the cloud, we could reach to that endpoint and know that that endpoint can be contacting to the device. So you're effectively able to send messages both ways. I like to think of this as a poor man's IoT hub, right? It was like one of the first things that we were doing that before IoT was a big term. This was really an enabling technology that let us think about, hey, look at this. Now we have messages that we want to get back into that facility. Now we have an endpoint here that we're able to connect that through. And so at this point in our architecture, we were thinking, okay, we need to get a way to get all this data out, and we want to be able to send messages in. So we decided that after we had done our initial prototyping and identifying our needs and what works and what doesn't work, we said, okay, let's make this new solution called Panoptix. And from a very high level, if you think about what Panoptix set out to be, it was basically a lot about what that gentleman in the video was talking about, right? He wanted to be able to be proactively notified of what's going on in their building. And not only just one facility, but multiple facilities. They wanted to know that if, instead of having to roll a truck every time one little message said that there was a sensor that was off, he wanted to be able to look at it and have analytics be able to look at all of the data and decide, that sensor's not the problem. It's something that serves that sensor that's the problem. And so every time that we're able to reduce a truck run to be able to see if there's a problem, we're able to save our customers money because they don't have to spend as long a time trying to troubleshoot. So when we set out to develop this, we did, what any basic developers would do. They set up their dev box and they started installing stuff on it. Right? We set up an IIS website, and we made a couple Win32 applications all in the .NET stack. We had a Microsoft SQL database, and we were starting to progress our application. We started working on our algorithms to do those analytics, to detect fault detection, to find where there were problems. And when we started getting to the point where we were ready to deploy this, we were still thinking just classical hosting, right? Persistent VMs or a bunch of server racks that you have, and let's load up these applications and load them. And what we found out was that we didn't really think about statefulness or sticky sessions or how we're going to handle cookies or persistence between your sessions when you're trying to send data to different nodes. These weren't things that we were thinking about. We were thinking about our core problems, creating those algorithms. And, what that really ended up doing was we weren't thinking of the system as a whole. So there was a bit of learning that had to be done at that time to kind of adjust our paradigm to adapt to that cloud-first type of thinking. So this meant, load balancing the web apps. This meant having many nodes so that we could run our tasks and services across them. as well as even clustering the database and figuring out how we're going to do disaster recovery. And with any sort of migration, when you're doing this, you're also trying to think about your code and the quality of that code. We have Tony up here because he's been with me from the very beginning on the whole Panoptix journey and all of the solutions that we've done since then. And he's been giving us key feedback into the architecture and trying to help us with those pitfalls. Is there anything you could think of that we should add or talk about that, that we were thinking at that early moment?
Well, I think, the earliest things, the things I was trying to communicate to you guys at the time was thinking about, minding statefulness. And you remember at the time, we were talking, we had, cloud services and, SQL Azure host, had like a 10 gig max or something like that. So, we were very limited in what we could do. And some of the decisions, as you look through this journey, you realize that the decisions that made are sometimes based on, you can also see growth of Azure in this journey because there were certain decisions that were made based on the roadmap.
Absolutely, and some services were available at certain times and some weren't. When we were at our earliest, though, persistent VMs weren't really possible. So we were still using our Azure Service Bus Relay as that way to get into the facilities, but at the core, we were trying to develop our cloud application that would run. And so as part of doing that with our quality assurance, we had several environments that we created. So, you start out with a developer box, and next thing you know, you have an environment for dev, you have an environment for QA, one for system test, and then you have your staging and production that are separate. And we actually decided when we started early that, we didn't want to take on that liability of having to manage those VMs. So we went to an external hosting provider and said, hey, can you stand up all these VMs for us and just give us access to install our software on them? And they were more than happy to oblige, and that's what we did to start off. But what we found was this ended up causing problems for us in that one example was we were gathering data from NOAA weather, right? Because we need to know what the outside temperature is to make some informed decisions on how our algorithm should work. And so what we were seeing is as we were doing our development, we would gather that data and would go through our corporate proxy, and there would be some manipulation that happens in IT land, and what we would see is, the information that was coming in looked in one way. And then we thought everything was groovy, moved through our environments and promoted up to production, and guess what? It broke. Because there was a difference in how the internet was connected and how those headers and all the messages that were coming in was being done. And so we broke the cardinal rule of deploy to dev like you would deploy to production. And here, we weren't failing fast enough because we waited all the way to production to find out that we had that problem. And so with all of these environments, we started queuing all of these VMs, and all those VMs made our lives look like this in kind of a metaphorical way because we're using VMs and not actual data centers, right?
Actually, I think your hair kind of looked like that at one point.
Maybe.
Yeah.
A little blonde, maybe, I don't know. But anyway, we had 300 VMs, 300 plus VMs across 8 different data centers. And we're not IT people. We are developers, right? And so we had a lot of things that we had to maintain and try to figure out how to, securely and make sure that we're not adding all these liabilities of taking care of things. So it was at this point when we had all these VMs and we had all these data centers and we didn't have any dedicated operations people that we realized the hosting struggle was real, that we needed to adjust how we were looking at things because the old familiar ways of doing business was no longer relevant. And so what we did was we did the next thing that we thought we could do was we said, okay, well, if we have 2 different types of hosting environments, why don't we just combine them into one? And so we went out and we got our own pipe power and cooling and got our own colo and loaded up a nice VMware server and got all those 300 VMs onto that server, and it was better. We were able to see production to be more similar to dev, but we still were having problems, right? We still had pets. And if anyone's familiar with this metaphor, it's, every single server that you love and care for you become emotionally attached to, and its quirks. And we had too many pets and not enough servers that we could just say, you know what, this server's not healthy. Instead of trying to fix it, I'm just going to nuke it and start over. And so at this time, this is when they began introducing Azure Cloud Services. And Tony was instrumental in trying to talk us into saying, this is what you need. And it took a bit of talking, but we started moving our platform over. Was there anything that you could think of that finally convinced us to think about that?
Well, it was the persistent VMs. This was more of a straight migration in the early phases. So, there were cloud services required certain architectural adjustments, whereas the persistent VMs allowed you to do more of a lift and shift initially, which I think we'll talk about that in just a minute about
Yep.
Where that kind of fit in on the journey and what challenges we faced along the way.
Absolutely. But the cloud services was the first time we could really think of it as like, we didn't need to maintain those pets. If there was an issue, we could destroy it. We could create a transient environment that we could use for a little bit and then blow away, which got rid of having to have so many VMs. And we didn't decide to go all in at once. We kind of decided to take a hybrid architecture, which, again, we're trying to evolve. We're failing faster. We're getting better. But again, look at this. It's complex as heck. It's hard to understand all these different services and how they're intertwined, and you had to be neck deep in it in order to understand what was going on. So even though we could make it work with the hybrid architecture, it was very hard to maintain. And so we decided at one point that we were looking at all these different business units and all of these different things and products that we had, and we said, we need to change the way we're doing things. We need to at least get all of our services into one data center. And so it was that point that persistent VMs were released, because we were following Azure to the very edge of the bleeding, or bleeding up to the edge. And we decided to go all in. So we began this whole movement to move all of our services into the Azure hosting, whether that be in cloud services or that be in persistent VMs. With Panoptix, it was kind of a hybrid of the two. We moved some of them in persistent VMs, but we tried moving the rest all into the VMs where we couldn't.
Right. So
just a quick review of some of the challenges. So as I mentioned in the beginning, load balancing was kind of added as an afterthought. Had I done it all over again, that would have been one of the first things that I made sure we did. Load balance early, load balance often, because it's so hard to do that after the fact. After you've created your code, it took a whole sprint or two, actually maybe 3, Chad would know, many sprints for us to get it right. And we could have done it right from the start instead of having to add it as an afterthought. A second thought that we had is that when we went through all these migrations and changes, is we weren't really shielding our customers from our change, right? We created a bunch of services that were, available to the internet because they needed to be, right? Our partners were connecting into our APIs and such, and we didn't really have a way to abstract them away from our change, right? So as we decided to change hosting providers, we had to switch DNS. We had to change connection strings. We had to do all kinds of things that were really painful. And in retrospect, and finally we got it right in the last migration, was we needed to put a proxy in front of it so that we could abstract those changes away from the customer. So as we decided to switch out a new version of our API, we could do that, and the customer is none the wiser because we have that proxy to shield them. Any thoughts on that?
Yeah, no, that's a big thing, because I always love getting the call from you guys. Hey, we built something and it changed our architecture. We can't deploy it for 6 months because we got to shut down all the customers along the way. It's important that you give the customer the interface and close the door there, so that you're not bringing them into your world necessarily. They're just seeing your service. The other thing, I want to land the point a little more about the lift and shift strategy. We talked about load balancing and those sorts of things. All too many times, I deal with many partners in this business. I've dealt with hundreds of them in Azure, and 80% of them say, well, we just want to take what we have and just plop the VMs in the cloud, which is great, good luck. But you've got to think about all kinds of other things when you do that, in terms of, is it an on-premise app that's a single VM? Is it, what's your strategy for uptime when you come to the cloud? How are you going to scale? Those sorts of things all need to be thought about. And those were a lot of the hard conversations we had after the lift and shift was done. So, just can't be understated.
Absolutely. One of the next points was about data, right? Any part of good hosting is to consider your capacity planning. And very early on, our sales guys, bless their souls, they were like, we're going to get 400 customers a month, and it's going to be awesome. And we were all excited, but then we started doing some napkin math. and got really scared because we were storing all of our time series into a SQL database, which, it's great it can perform really well. It's a great technology, but it's not necessarily the cheapest if you're just going to infinitely scale it and keep data forever, right? So we figured out that was going to be about 74 gig per year per customer, which if you're storing, 30 years of data for a customer, it can add up really quick. And if you think about SQL, you need to not just have one instance of that database, or database server, you need to have a cluster, so you need to have many of them. And that increases the cost quite high. And our concern was that if we keep using this technology, is it going to make it way too expensive for our customer? So it was at this point that we said, hey, do we need to start considering the big data? Because that was the big buzzword at that time. Big data, everything. It kind of is still.
That was me walking around there going, you guys need big data. You guys
Big
need
data!
big data. Yeah.
So anyway, we were like, do we need to go all in on this? Looking at that 400 customer a month projection. And what we determined in the end was that we didn't really think we needed it at that time. We decided to take the middle road and look at a different technology as Azure Tables. Because while we were confident that our sales folks would do their very best and that we would have good success, we weren't ready to go all the way in on the big data thing. So we decided to look at Azure Tables, and it was actually an excellent choice for time series because the way we could do it is we would have a table for each customer, and then we would partition by the ID of the sensor that we're gathering the data, and then also the time or the date of that. And so it partitioned very nicely for us to use as one of our first iterations for our time series store. So in reality, we were trying to create an application that would empower our customers to have better insights, right? But the key underlying thing was we created a connected data platform that irregardless of what the app was doing, we had really valuable data. And we basically said that we were able to move everything from our traditional naive implementation all the way into an Azure hosted. But one of the things that we realized is that when we were delivering it, remember that huge chart with all the little icons in it? We had all these tiny little microservices, before that was a buzzword too, I think. We had all these services, but we were still deploying them as a monolith, right? We released all of them at the same time, so it wasn't really microservice-y.
There was no agility to it.
No, there was no agility. And every time that we had a change, everything had to roll out, and it was very, very painful. And what we found with the Panoptic solution was that the initial cost and complexity of our investment for our customers was really high. For them to integrate to the system, it was really painful for them to do. So we had multiple portfolios of these solutions that could do something, and we had a really great underlying platform. So we looked at the rest of our solutions, and there was, this was just part of our journey, right? We moved one whole platform over, but we still had other platforms out there that we needed to migrate. The next one we looked at was Metasys Energy Optimization, and it was very similar to Panoptics, and still is, very similar in what it set out to do. It wanted to get all that data so that we could provide insights for our customers. It was just kind of a different application implementation that we used for very specific things. But in the end, it's basically still a connected data platform. It was gathering data, it was aggregating it, and providing it value back to our customers. So the architecture that we had for this was pretty simple. It was just a whole bunch of VMs, which each one of these boxes is a VM.
I like how you define simple.
That's pretty simple-ish. Simple adjacent, I don't know. Simple-ish. And so what we decided was with Mio, because we didn't want to undertake a huge transformation of how that application worked, we decided to take the classic lift and shift maneuver where we basically created new VMs in Azure and installed our application into it. So it wasn't technically a lift and shift, it was more like a copy and shift, but you get the idea, right? What was instrumental here from a technology standpoint was at this time they had introduced the Azure Resource Manager templates. And what this allowed us to basically do is create kind of one base template and then kind of customize it for the different tiers of services. So we had like web tier, we had app tier, and database tier, and so forth. It really sped up our delivery time because we were able to reproduce those templates very quickly without having to start over from scratch on each VM. So some of the lessons that we learned from the Metasys Energy Optimization was that code can be fragile, right? as soon as you try to move that environment, you find that you had a lot of technical debt with there. There was a lot of knowledge that through years of development, folks had left, new folks had come, and the people that originally created that, we had a whole bunch of pets, basically, going back to my previous analogy. And it made it really complicated to try to reattain that knowledge to build that environment again. One of the things that remains to be kind of a concern for us is that our database strategy is based on hoping that we have a bigger VM. When we were running our own hardware, it was pretty easy to throw more iron at it, right? We could just throw more nodes in there and just keep going, right? But with Azure, it's been great because every time that we started approaching our maximum capacity, they came out with like, hey, here's new VM thing, yay! And not a tragedy today, but it's still going to be a tragedy at some point because you can keep scaling up, but eventually they're going to run out of numbers to add for VM sizes. So it's really important to consider, that you need to do the scale out sooner or later because you're just postponing the inevitable. So we're continuing to look at new technologies that might help us in this, especially for MEO, such as Azure Data Factory to get the data and move it around, data warehouse, data lake, et cetera, right?
Right.
And Tony knows a thing or two about data here.
And the other thing I wanted to reinforce was the code as pets analogy, right? VMs can be like pets, but code can be like pets too. And a lot of times when you move on a lift and shift, I see a lot of talk around, well, we can't change that code, or we're not going to go rewrite that code. We're not going to touch it. I mean, if I polled this room right now, about 90% of this room would say they've been on some project where they've had to do that. When you move to the cloud, that code will almost always burn you in some way, unless it is just the simplest pieces of code. So, make sure you fully understand what the code is and what it's doing before you migrate 20-year-old code to a cloud application that's expected to scale. That's my 2 cents on that.
Absolutely. So now we've got 2 products that we've migrated, right? We spent about three or 4 months moving Panoptix. We spent another 3 or 4 months moving MEO, or Metasys Energy Optimization. And so the next thing that was kind of on our migrate list was Connected Chiller program, which the video that we saw earlier, again, that was specifically about. And the Connected Chiller program is actually a pretty interesting one because, again, the cost of investment is so high for the building owners to invest in that, providing them that value back early and letting them know that they have a problem is invaluable to them to maintain their facility.
Yeah, I don't know if that point was it was said in there, but I feel like it should have been screamed. It was, that time where somebody showed up and they did some proactive maintenance based on alert they received and saved them $300,000 an hour in downtime. I mean, it pays for itself.
Yeah, waking people up in the middle of the night to say, hey, go fix this chiller, they might not have the part to be able to repair that. So being able to know that we need to do that, or even combining it with some of our business processes to say, hey, we know where this part is because we're connected in, we know what model this is, and we can join all that data together. There's an infinite amount of ways that we can help our service folks get the information they need in order to solve problems much quicker. But in the beginning, what we ended up seeing is that we had these applications that were kind of isolated, and we talked about that the customer site, when they started, was just basically the data was there. It was facility aware, but not globally aware. Well, what we started doing was creating this application, but it was more, I guess, continent aware. We would have different data centers that, customer A, customer B, customer C, they would gather the data and it would go to Europe, and then we had a whole nother instance of that running in North America. So we were more regionally aware, but we weren't globally aware yet. And so as part of the Connected Chiller migrations, we said we really need to look at how we're doing this and try to find a better way, find a way that we can kind of pull them all together and use big data for the first time, right? So the initial system that was being used, or the primary system, was being hosted in Europe. And at that time, our company went through a divestiture where they said, okay, in the breakup, they're getting the data center, so you got to move your stuff out, right? You don't have to stay. You don't have to go home, but you can't stay here. So we need to rehome those services as quickly as possible. So it was a little bit sooner than we were ready to because we were planning on this bigger migration. But because we'd done 2 migrations already, we said, why not? We can do this. We just did a lift and shift with Mio, so let's go ahead and try that with connected chillers. And we did. We moved all those services from one VM to another VM. And then the second part of the migration, which we'll get to, we kind of more modernized it. So this is a pretty, again, simple, I keep saying that, it's simple architecture, but it's anywhere but simple. But
it didn't feel simple at the time.
It's a few servers that we had to migrate, much fewer servers that we had to migrate, a web server, an app server, and a database server. And we were using Apache Hadoop on-prem. So we had in our own GCI data center, we had a Hadoop cluster that we were running Hive, we were running HBase, we were running Thrift, all on that cluster because we owned it, we could do whatever we wanted to it. And it was working out all right. So part of this migration was, hey, how do we get this up into the cloud? How do we rehome it into being persistent VMs? So what we did first was we spun up those new VMs using those ARM templates we created for Mio. Again, reuse is cardinal here. Created new subnets for each one of our tiers, so one for the web tier, one for the app tier. We put the database into the app tier because it was just simpler at the time, even though it doesn't say app, it says data. But anyway, details. We spun up another set of VMs for the app service and basically migrated all the services over. At the time, I think it was pretty much a new service, wasn't it?
HD Insight was brand new.
HD Insight for Windows was brand new. It was fresh off the press. Is there a press anymore? I don't think there's a press. That's not a thing.
There's probably a blog post.
There's a blog about it. So we had a HD Insight on Windows, and so we jumped right into that, and we were migrating our roles into it. But again, we were mostly focused on trying to get those persistent VMs moved. We had VPN tunnels that were still going back to our on-prem system, so we were able to do kind of a back and forth and make sure that everything was working. But all in all, we were able to get everything migrated over there and get our data sources reconnected up to push that data in. So on to the next phase, right? So we got the persistent part moved. Now let's modernize it. Let's try to make it more good or better. So what we did was we looked at the Azure App Services. What was it called? Was it called Web Apps then? Mm-hmm. Web Apps. It's hard to keep up with all the terminologies. But at the time, it was Web Apps.
It's still called Web Apps.
Is it? Yeah. Wait a minute. It might change. So we were using Azure Web Apps, which were much nicer because it had built-in load balancing. It was easy because you didn't have pets, right? You could just destroy those sites and recreate them ad hoc. We use web jobs for all of the Win32 processes and such that we're doing some data injection, so grabbing data from one place and inserting it into another, so typical processor workload type stuff. We moved from on-prem, a persistent VM, into a Azure VM, persistent VM, and then we migrated that. It had SQL Azure on it. No, it didn't have SQL Azure. It had SQL on-prem in buzzwords, killing me. We had regular old SQL installed into the VM, right? And so as part of the PaaS migration, we moved into SQL Azure or Azure SQL, whichever way the name went at the time. And we moved over from HBase on Windows into HBase on Linux. What we learned here was that HBase on Windows didn't have, I guess, on par with the same type of memory management that we were used to on HD Insight. Well, it wasn't HD Insight, on Hadoop on Linux.
Yeah,
right?
I would say that Johnson Controls in this case taught us quite a few things because we spent a lot of time working with Johnson Controls because at one point you guys were the #1 consumers of HBase in the world on HD Insight, running on Windows. And I think the thing that the product team learned as we worked through this is, you've got a back-end service, again, shielding our architecture from our customers. HBase was built on Linux. Working on Windows, it didn't work as efficiently as it did on Linux. So we helped you guys migrate back. And, the learning was kind of that even though it's as a service, the Linux implementation seemed to work a little bit more smoothly and more efficiently as we went. It scaled better and it did some things better.
Absolutely. Yep.
So, that was one of the things we were able to learn working with you. And those are the kind of learnings that we like to take and share, and so.
And it was a bit interruptive to us. We did have some rough road, but the important thing was that Microsoft was pretty responsive with us. We had direct pipe to the developers, and the whole team supported us throughout the whole journey. So we were really fortunate in that way, and I think that really helped add to the success. And hopefully we helped work out some of the kinks for other folks as well. What we added in that last iteration was actually another cluster for Apache Storm. And what we were using this for was because we had gone through this migration, so we did Panoptix, we did Metasys energy optimization. We had a lot of different data sources, and what we wanted to do was try to leverage that data, pull it out, and get it into this platform as well. So we used Apache Storm to do that as well. And so that was part of the addition in that last migration that we were able to do. So our final architecture looks something like this. Going back to our original slide, we have the chiller or the customer's site. And on that site, they still have that database that has that information. And so via our first platform we talked about, Panoptix, what we did was we were able to redirect some of the data. In addition to sending it to Panoptix, we also sent it to event hubs that could later on be captured by Apache Storm, which would then also pull data from blob storage. So MEO, or Metasys Energy Optimization, was putting its data into blob storage. So now we have 2 data sources that are coming into Apache Storm that is we are able to run bolts to be able to find alarms if there's a state that is detected that is unsafe or that it's going to put the equipment into an unsafe state. We're able to send notifications to our customers using Apache Storm. And we also used, just as before, Apache HBase to store that data. So we're using HBase primarily in a way to store time series. So in Panoptix, we were storing it into Azure Tables, and in MEO, we were storing it basically into a SQL database. Well, since we had so much data that was coming in, we decided to use HBase to make it happen for connected chillers. We use Thrift Services as basically an intermediary for our services to be able to talk and retrieve data from our clusters. And we use SQL, Azure SQL, to store our metadata. So when you talk about a building, you need to be able to describe that building and what equipment is related to what equipment serves which space, all those kind of things. We use SQL in order to store that data. And then we created Azure Web Apps to host the application that our users would actually connect to actually get their information, as well as Power BI to be able to create dynamic reports that the user can interact with. So at this point, we have a pretty neat system, right? We have 3 different ways of data that we're creating data, and it's going in through different paths, but it's all able to get into that HBase cluster, which is storing all of our time series. And in the end, we were able to pull off the entire migration and able to get the application to work. One of the major pitfalls that we had during this migration, though, and I think it's worth noting, was that we had some incompatibilities along the way. So as we were migrating from using HD Insight on Windows to HD Insight on Linux, there were some differences. At the time, HD on Windows could only run on V1 networks, and Apache Storm on Linux could only run in V2 networks. And when we looked at HD Insight for Linux, that could only run on V2s. So what we ended up having when we were in the intermediary state was we had a bunch of stuff that was on our V1 network, so our web rules, our app rules, our database, our HD Insight was all on a V1 network, and then we had another network that was hosted in Azure that had our Apache Storm in it, and so that made us have to have a VPN tunnel between those networks, even though it was hosted in the same data center, and probably sitting right next to each other. We had to do a VNet to VNet connection because that was before they had VNet to VNet stuff. And so it was really painful because we had a lot of bottlenecks in that as well. So it was very painful, and we had to work very closely with Microsoft to try to work through those issues. And luckily today, I don't think that's a problem anymore, right? Right?
Not that I'm aware of.
Okay, good.
You guys aren't complaining.
We moved everything to V2, so we're good. So we are using HD Insight on Linux. So the other thing that we found that we were doing is we were mistreating how you use Hadoop, right? We typically, when you're talking about how you want to host your roles on your Hadoop cluster, you can have MapReduce, you can have Hive, you can have HBase, and you can use all of those nodes and have multiple roles installed to each node. But when you talk about HD Insights, it was really meant to be more of a single purpose type service, right? Let's say you get audited and a huge corporation, and to do that manually would be really expensive. You'd have to spin up a bunch of servers. So instead, you send all that data up into the cloud, and you have HD Insight burst up, and you could do a bunch of analytics on it. And then as soon as you're done with your audit, you can spin them down, and no one's the wiser. Well, we were kind of abusing it because we were trying to do what we were doing on-prem in Azure using HD Insight, and it didn't really translate very well. I think at one point we had a couple was it a couple hundred terabytes of log files because we were logging to somewhere that they weren't expecting us to be logging.
Well, that
It
was one of
weird.
the Windows things
Yeah.
before there was a misconfigured property in the template that had caused logging to never get truncated. So
Yep.
8 terabytes of data turns into 140 terabytes of log files.
It gets weird fast.
It gets real weird real fast.
So overall, I mean, the Connected Chiller program was a huge success for us, right? This slide originally, I think it was a couple, 6-9 months ago, it said 300,000 or 3,000 chillers at the time. Well, now it's up to 4,000. So we're growing that business. We're getting more and more chillers. We have over 85 different types of chiller models. So I'd say that all this data that we're able to do and migrating, has helped us expedite that because we're able to provide a more consistent service. So what's next, right? We went through all of these things, and you've seen this evolution. We went from Panoptix, we went from Metasys Energy Manager, now we have Connected Chiller. We were able to get all of our rest of the applications up and hosted in Azure. What's next for Johnson Controls? What are we trying to do? So let's talk about the architecture really quick. Fundamentally, the first class citizen is the edge device, right? We have the edge device sitting there, and we're using a trusted platform module to store the identity of the device, which helps with our device management and such. But that trusted platform module basically has that unique identity for that edge device. And we're using IoT Hub as the not-so-poor man's IoT Hub nowadays. So we don't need to use Azure Service Bus Relay anymore. We can use that to send our telemetry data into IoT Hub, and we can also create these services, our security suite, that we're going to use to basically secure that data, right? We want to make sure that as data comes in, we can make it very granular as far as what service can gather what resources and whatnot.
Yeah, I think there's a couple key points to note here. Number one, in this platform that Johnson Controls is thinking of, they said, okay, we're able to capture data from connected chillers, run analytics on it, reduce the downtime, and it's just time series data. So why can't we do the same thing with our rooftop units, with thermostats, with controllers, and everything that they've got running, the thousands of devices that run a building? Why can't we start capturing all of that data and start writing analysis to come up with a more holistic approach? And the data platform is the first step in doing that. That said, when you go down that level, all of a sudden you get into buildings, and you have multiple levels of security, right? In any building, you have the building owner, you have the building management, you have operators, you have installers and servicers, you have the tenants, and you have Johnson Controls. And all these people, the thing that they wanted to think about was, how do we secure not just the ingestion and make sure that the devices are secure that are bringing us the data, but how do we secure it so that the people that view this are the people that actually have the right to view that data from that device? Because you don't want somebody that is a building tenant maybe viewing somebody else's next door's data, or another level or another floor. You don't want to have that access, because funny things happen when people can figure out environmental data. And so, by building these APIs, the security suite of APIs, and integrating it with Active Directory and some of the metadata from IoT Hub, we were able to tie the devices to the users, to a role, and allow access to the data, in addition to restrict access to the data to only the people that should be able to see it, in addition to securing the devices that are transmitting the data. So it became a holistically secure platform.
Yeah, absolutely. I mean, just think about occupancy, right, at your home. Do you want to let anybody that can get a hold of your data when you're home and when you're not home? I mean, it's a huge risk. And so making sure that you can secure that data and that only the people that you trust and authorize to have the access to that data, that's a central theme to how we're thinking about how we create this. And one of the other things that we've learned is that we're going to change, that we're constantly changing, and that we don't always have it 100% figured out. And so when we designed our services, we kind of called this out as a little more level of detail than you would have thought. But the idea is we wanted to show that we're trying to abstract it out. We have one layer that's basically for our front-end APIs, so that as we are delivering our software, we can maintain those contracts. And if we were to say we wanted to switch out to a new technology, we could just swap out that front end. And the back end, say that we want to be able to store it in one type of data store versus another. We have different type of repositories for each type of thing. And then in the center, we have our business logic. The idea is that at any time, any one of those layers could change without having to interrupt everything. And it makes things much more testable and much more repeatable. So moving along in architecture, we also wanted to be able to say we had data, as we were showing, that you could send data from the edge device into the cloud. Well, we also need to be able to send data into the IoT hub and down to the device. And so we saw that it was important that we added into our security layer that capability that we could request a command or a cloud to device command be sent down to that device. And so going through the security API is the only way that we thought that would make sense to make sure that only the right kind of commands are making their way there.
Sure. Yeah. Like for example, we're talking about environmental controls, but if you were to say turn on the lights in this meeting room, you'd only want certain people. You wouldn't want. Nobody would want me to be able to turn the lights on and off in Satya Nadella's office.
Or your 2-year-old that's just playing with the switch, right?
It's important to know who has access to control those devices.
Right. And auditability. Who did it? Right. When was it done? So next, that time series that we're sending, how are we collecting that? So again, we saw a lot of data platforms that we were gathering. Well, in this iteration, we kind of tried to do that layering approach again, where we had the web job that's gathering that data from the IoT hub, but we were also using it as like a great Plinko board. And any Price is Right fans out there, I like to think of it as a Plinko board when you have time series, right? You put the little time series in the top, and then it rattles down through different event hubs until it finds its way into the right bucket. And that's kind of how we're using it, is we have a series of event hubs that as we are aggregating and doing different types of operations to it, it can go down that Plinko board until it gets down to the bottom, and then our time series API can be used to access that data out in a secure way using our security API.
Yeah, and we spent a lot of time focused on the right data storage for this. There were some heavy conversations. We talked a lot about running OpenTSDB on top of HD Insight. We talked about the new time series insights database system, which has been talked about during these build sessions. It's a great product. At the time we were developing this, they weren't going to be ready to meet our timelines. It may be something we investigate in the future going forward, but we needed to get something done now. So they implemented their own API and their own method of handling that data, handling data that comes in out of order and late arriving data and all kinds of other things, and using web jobs and event hubs and Cosmos DB and Postgres to handle that. And, it was really interesting work to come to that solution.
Yeah, and if we learned anything at all, it's that we don't know what we don't know. So we want to make sure that we make our solution such that we can deploy it on what's appropriate. So if we wanted to deploy our solution on-prem, we could use a Postgres database instead of using Cosmos, right? Similarly for the security API, we could go to Cosmos to store those documents, or we could send it to Postgres. It just takes a little level of abstraction in order to be able to swap those things out rather easily. And then, of course, our picture wouldn't be complete without some device management and the sales and manufacturing folks to connect to it to configure and set up those devices. So the key tenets that I guess that we're considering as we're building this platform, we're rolling it out now. Some of our internal applications are starting to consume it, which will be released very soon. But some of our key tenets that we're trying to learn from is that we need to learn from our previous cloud experiences. And I think that we're doing a pretty good job of that. We need to make sure that we're providing options to scale to the right appropriate level of hosting. So if you're on-prem, you don't necessarily need big data. Maybe using a SQL database is fine. We want to be able to support multi-platform, right? So we need to be able to do Windows for IoT, Linux, and all the like. And if we want to remain highly available, we need to make sure that we not only host within just one hosting provider, but actually have multiple solutions. Maybe, one hosting provider goes out, we can have another one that we can scale over to. And most importantly, I think, is that we don't want to disillusion any of our customers. We want to make sure that with any of the data that we're gathering, that data is very valuable to everybody that's involved. And so we want to make sure that there's always a way that we can get data from previous implementations and get them into a modern one. We were going to show a demo, but why don't we just power through here? I don't think we got a whole lot, or do you want me to show it? Or?
Go ahead.
Yeah, okay. Go ahead, Justin.
So here I thought it would be just kind of interesting. This is one of our applications that we're developing right now. It was called Metasys Energy Management, and this is kind of a brief little snapshot of what it looks like. And what it's doing here is it's basically gathering meter data for a fictitious Stark research building, right? And you can see that the way that the data patterns are going is that during the week, it goes up every day, and then it goes back down in the evening. And then over like between the 6th to the 8th, you can see that the energy consumption went down to a medium line, or the minimum, and you can see that that's probably where the weekend was. There wasn't people that were in the house, or the building rather.
Yeah, and along the lines of that security model, I just want to point out that if you had this data, you would know that the Avengers don't work weekends.
Yeah, it's true. That's true. I hadn't thought about that. That's good insight. So this is just an example of what you can do with the data. It's a very simplistic view. I mean, we do so much more with that. But for the case of this, I just kind of wanted to show a pretty picture. And I think it shows that we do have a solution that we can use in the real world. So some closing comments was, again, this was the extra credit. So if you want to tune me out for the next minute, I guess you can. But number one is design for the real world, right? Design for the world that we're in and not the world that you want to be. If you have some sort of requirement analyst in some, closet down the hall that's just, banging out a bunch of requirements and not thinking about the real world, you're not going to get the solution that you need, because, the optimal solution isn't always a solution that we have to live with in the end of the day. So be realistic with what you're building. Secondly, design for easy adaptability. So we talked about those abstractions. I like to call it as nanorification, I think is what the term I came up with yesterday, was basically nanoing the microservice. So making more smaller services so that you're able to actually, that microservice might have one purpose, but if you look down the next layer, you can actually make those even smaller, and maybe they don't care about the full system, but within that microservice, it's a system in their own right. Number three, you should always consider designing for security. It should go without saying, but we should constantly be diligent to look at how do we reduce the surface area of what the code is. Are we making sure that we're only exposing the things that need to be exposed? Those kind of things. DevOps the world. This is one of my favorite things. It has totally changed my perspective in things. There was a book by Gene Kim called The Phoenix Project. For anybody that's interested in reading it, it totally changed my perspective in how we as application developers need to think about the world. And the three things that Gene Kim talks about in the three ways is deploy systems thinking. Look at the entire system and figure out what the least common denominator is. If you have a shop floor that has a bunch of pieces of equipment, the worst performing equipment is the only place that you can really make the entire process more efficient, because even if you fix every single other piece on that manufacturing floor, that one that's still not operating optimally, that the work is piling up on, that's the one that you need to fix, not everything else. Make sure that you're increasing the amount of feedback loops you're getting. Don't wait to find out if you have the right solution or not, and always be trying new things. So it's important to note that I love shiny objects. I'm a big fan, always have been. I love new technologies. I jump probably too far in too quick. But nowadays you can't be so quick to jump into a technology because it might not last. And I'll admit that I've gotten burnt many times. Anybody decide between HD DVD versus Blu-ray? I chose HD DVD. So now I have this great HD DVD player that no one uses that. It's like beta and whatever. Anyway, I rambled. So in review, going back to my main 3 points, avoid focusing on technologies, focus on outcomes. Learning hurts. Make sure you make good partnerships. There's always more you can learn from people around you. And fail fast and fail often.
Great. Well, thank you, Justin. That was really, really, really awesome, at least for me. I hope you guys have learned a lot. One of the main questions that we get is, well, how can you apply these learnings to what you guys are building? Like, how can you get started? And so here's some of the things that I guess Justin covered quite a few of them, but just to review, huge lift and shift migrations rarely go smoothly. Like, you want to try and go for some of those low-hanging fruits, some of those not so critical pieces of your solution as you look to migrate your solution. That will also give you a sense of how the platform works and how should and also help your developers get used to the platform. And so always go for those low-hanging fruits before you go and move your critical pieces. Optimize for the cloud. Again, on-premises, the way you've been designing for on-premises is not the same way you design for the cloud. And so have that thing in the back of your mind as you start to write code for the cloud. API-first approach, I think that's, as Justin pointed out, they are going for that microservices approach. You want to try and keep it as modular as possible. So if one thing goes down, only that one thing is going down, and it's not affecting the rest of your application. And always keep that in mind. It's very, very, very important. designing for disaster recovery. This is something we really ignore quite a bit, including myself. We don't design for disaster recovery, right? And disasters do happen. So unless you or your company wants to be on the first page of the business journal, I'm telling you, you need to start thinking about disaster recovery. And finally, low latency and high throughput. Customers do not want to wait when they're looking for responses. So just some guidelines. But let me also show you some examples, right? So how do you design for low latency? In a normal situation, you've got a web app, and you go ahead and send a request that's going to go talk to an API, and then that's going to go to my database and get my response back. But what happens if my web app goes down? So in order to get disaster recovery, I'm going to go ahead and add a traffic manager, deploy my web app in 2 different regions, and voila, I've got my disaster recovery sorted. But then you still have a single point of failure with the API. So what do you do with the API? Now again, with the API, if the API goes down, I can go ahead and start applying disaster. I can start replicating it, and I can put a traffic manager in front of it so it can divide my load and do different regions. But now what happens if your database goes down, right? So you need to always keep thinking about, hey, do I have a single point of failure in my application, right? That's the most common thing to always think about. Do I have a single point of failure? And so in that case, if your SQL database goes down, well, today, luckily, most of the cloud services we have within Azure, and especially the databases like Cosmos DB, SQL DB, HD Insight, they all come built in with disaster recovery. And so you can easily create a geo-replicated database. And so then that way, if your database were to go down in one region, you can easily bring it back up in another, right? I mean, we all know that outages happen. It's not just Azure. It's not, every cloud platform is bound to have some sort of a disaster at some point. And so you as application developers need to always keep that in mind as you design it, right? Always keep that in mind. One more thing I wanted to talk about was some of the common data stores that we have within Azure for different types of workloads. This is actually one of the common questions we get, which is, when do we use which kind of data stores, right? You've got your, honestly, even though we're in the cloud, how you do data processing hasn't changed, right? You had your traditional ETL, but you've got something different too, right? Now you've got your ELT as well. There's some data stores that are meant to be those transactional data stores that can provide those millisecond latency and those really fast throughputs and low latency and so on and so forth. But there's some data stores like the ones at the bottom, such as your HDFSs and your data lake stores, that are actually meant for those high, kind of like large data sets, right? Those are not meant for throughput. Those are meant for storage. So when you're storing terabytes and terabytes and petabytes of data, you want to consider, sort of like a warm store or an archival store. But when you're trying to serve data to an application, to a front end or something like that, you want to try and use like a OLTP or an OLAP store, right? And we've got Azure Analysis Services. So if you're trying to do queries on runtime, for example, if your CTO is trying to figure out, is trying to create reports on the fly, your data store needs to be flexible enough to handle those high throughput queries. And so you want to use something like Azure Analysis Services. But if you're just trying to pull down data, just pull down data without doing much querying, you can use an OLTP store. You can use a Redis cache. You can use Cassandra. You can use quite a few options there, right? You can use Postgres that we just announced, or MySQL. Those are meant for your kind of high throughput, low latency workloads. Finally, just another slide before we're done, is what's the equivalent between, just like a crash course between Azure HD Insight. This is one of the open source technologies that we first adopted within Azure, and it's very hard to understand how the open source stuff maps to the proprietary technologies that we have within Azure. We support all of these, including the HD Insight pieces and the Hadoop pieces, but it's important to know that even if you're not doing Apache Hadoop and everybody's asking you to go do it, there are other alternatives for you as well, right? We can do every single thing that Apache Hadoop or any other technology for that matter of fact, you can do. You can do it in, there's a Microsoft equivalent for that. And so again, to Justin's point, avoid focusing on technology, right? Focus on the problem at hand, focus on the solution you're trying to build, and then bring in the technologies in as they fit in. And that's it. I think from a standpoint, as you guys are looking at other sessions, tomorrow morning we're doing a Q&A. So if you are interested in different data services, we're going to have the people that build the Cosmos DB, people that built Azure SQL, MySQL, Postgres. We're going to have them in the panel. So if you guys are interested, 9 a.m. we'll be hosting a Q&A session. I believe that's going to be on the 4th floor. Our vice president's going to be there as well for the data platform, so it'll be a great chance for you to ask questions about the future and the roadmap and how we're integrating the different services together. I know one of the questions that always come up is, when are you guys going to support SSIS on Azure as a service? So something for you to think about as well and ask. We've got other sessions as well. Some that have finished, some that are still going to happen. But these are all going to be available online for you. So even if when you go home, you can look at these. These are all going to be uploaded on Channel 9, and go through them. They're great. Also, just a quick call out. B8081, that was something we did, which was kind of like a data platform State of the Union, where we talked about where we are from a Microsoft data story standpoint and where we're headed and how we're embedding AI within all of these different data services that we're talking about. But thank you again for coming. I hope you found this useful. Hope you guys enjoy the rest of the build. Thank you and good night.
Thank you.